Regression analysis is one of the most frequently used tools in the world of finance. It quantifies the relationship between a variable, called dependent variable, and one or more explanatory variables, also called independent variables. Regression analysis can be handy when we want to forecast a future dependent variable with the help of patterns from our historical data. Let's go back to the example we mentioned before: house prices. The larger a house, the more expensive it is, right? In this relationship, we are considering two variables: the price of a house and its size. The explanatory variable is size, as it helps us explain why certain houses cost more. And the dependent variable is price, as it is being explained. And we know for a fact there is a relationship between the two. So, the basic reasoning is that if we know the value of the explanatory variable, house size, we can determine the expected value of the dependent variable, house price. There are many other factors that determine house prices. Size is one, but it is not the only one. If we use only one variable in a regression, it is called a simple regression, while regressions with more than one variable are called multivariate regressions. Simple regressions are easier to understand, so let's start by describing a simple regression. The two variables we have are x and y. Y indicates prices, and x stands for house size. Okay? We can use the xy plot we showed earlier. Each observation we see in the plot contains information about the actual size and price of houses listed in a newspaper ad. Great! We can easily see the two variables are connected. Larger houses have higher prices. Regression analysis assumes the existence of a linear relationship between the two variables. One straight line is the best fit and can help us describe the rapport between all the data points we see in the plot. How do we determine which is the best line that will help us describe the relationship between house prices and house size? Well, we simply have to find a line that minimizes the error observed between itself and actual observations. See how different observations tend to deviate? A linear regression will calculate the error observed when using different lines, and will determine which one contains the least error. Each deviation from the line is an error, because it deviates from the prediction the line would have provided. We have all done basic algebra, right? Remember the equation of a straight line, also known as a linear equation? It is y equals mx plus b, where m is the slope of the line and b is the y-intercept. Great! Given this is a linear regression and its output is a line, we would expect to obtain an equation with a very similar shape to this one. Most textbooks show it as y equals alpha plus beta times x. But that's basically the same, isn't it? Alpha replaces b and beta replaces m. Perfect. Later, we'll explain the financial meanings of the alpha and beta coefficients. However, before doing that, we will learn how to distinguish between regressions that are solid in terms of predictive capabilities and regressions that are weak and unreliable.